So there are a couple of questions in the chat. The first one says, does the fact that we have 3 independent loops mean that the parameters related to the other 3 loops are perfectly determined by the ones related to the independent loops?
Yes, that's right. Yes, they could be worked out from the parameters for the independent loops, and so algebraically we could write down how they were related. That's right.
There's another question saying, can we really assume that there's no inconsistency just because the p-value is larger than 0.05? Absence of evidence versus evidence of absence. Wouldn't make it more sense to look at the effect sizes?
That's a very good point. And yes, I probably talked a little bit too much about significance. So yes, I agree that looking at the effect sizes is important, and p-values always have to be viewed alongside effect sizes. So for example, in the diabetes example where the p-values were 0.11 for the loops which were showing the strongest evidence for inconsistency, I think probably investigators might think it was worth investigating potential causes of inconsistency in that case.
Does this method apply for checking consistency in fractional polynomial-based NMAs where estimates are often time varied?
Oh, I have to say that I don't really know about fractional polynomial-based network meta-analyses. I don't have any experience with those. But I don't see why the same method couldn't be used. So the estimates would be time varying. I think we could define the same model. So the loops, the structure of the network would be the same. And I think we could identify the independent loops in the same way and fit a similar model, but with time varying estimates, I think. But I'm not absolutely sure about that.
The next question says, how has the outcomes of this method compared to other test methods for inconsistency?
So this is something that we're planning to look at in our next stage of this work in a simulation study. So we haven't, we've informally compared the results, but we haven't formally compared the results alongside other methods for inconsistency. So this is future work for us.
Okay. Does null hypothesis testing make sense in regard to inconsistency, since the null hypothesis assumes perfect consistency?
I'm not sure. Does it? Would the speaker like to expand on that? I mean, would the person who asked the question like to expand on it?
Yeah, maybe Robert, you want to unmute yourself and explain a bit the question?
Robert, if
yes, hello. Hello, do you hear me?
Yes.
Yes.
Okay, thank you. So my question was about, I guess, in larger networks, or in networks generally, we assume in the null hypothesis that there is perfect consistency, that we have no inconsistency. But that would also mean that all treatments or that all studies are somewhat perfectly similar. And I guess, especially in larger networks with more data, tests for statistical significance will always be statistically significant, even if we just have the slightest inconsistency that is practically irrelevant.
Okay, so you're saying when there's a lot of evidence,
Yeah.
we will over detect inconsistency.
No, not exactly over detect. I mean, there's still inconsistency, of course, and the test will be correct from a statistical perspective, but it will be practically irrelevant.
I'm not quite sure that I'm following. So you mean in large networks where we have a lot of evidence?
Yeah.
So this would be the same issue for all of the tests for inconsistency, wouldn't it? All the methods for testing for inconsistency.
Yes, especially when we are just looking at the p-value, because I mean, we also have the same issue when we are testing for heterogeneity.
Yes.
That in larger meta-analyses, these tests will always be statistically significant. And hence, it doesn't really make sense to just look at the statistical significance, because these values will always be below p.05.
Okay, so this goes with your previous point that it makes more sense to look also at the effect sizes alongside the p-values from the test.
Yes,
and so to
yes.
interpret, so we should interpret the p-values with the effect sizes and thinking about what impact this really has on the analysis.
Yes.
So we could look at the difference between the results from the consistency model and the inconsistency model and see whether it makes any difference. And
exactly,
that would be helpful. Yes, I agree. Okay, yes, I agree with that. Thank you.
Thank you.
Okay. The next question is there a criterion to choose among different possible models when the number of available pairs is high? I guess the number of possible models explode, so not all of them can be examined.
Okay, so can I check? So would it be possible for the person, Federico, to unmute yourself? Could I ask you, are you meaning models, different methods, different inconsistency models for the same data set? Or do you mean, for example, our model, but including different numbers of loops?
No, hello, I mean the different way, I mean the different choice of the set of independent loops. So for example, when you only have 4 treatments, you showed us there were 3 possible methods, but I guess if you have 30 treatments, maybe you have hundreds or even thousands of possible methods. And so I guess there must be a criterion to select one. You cannot explore all of them.
Okay, so I think you're meaning the issue about whether we minimize or maximize the number of loops in the model?
No, even I understood that you want to minimize the number of loops, and this is related to my other question actually. But even if you have the same number of loops, still I think you have the choice between so many options that I think there must be a criterion.
Oh, I think so. I think you're meaning the different ways of parameterizing the model because there are different possible sets of independent loops.
Exactly.
Yes.
Exactly.
Okay. So that doesn't, we found that doesn't matter because our model will be identical in each case. So our model is invariant to the set of independent loops. So even though there are potentially a lot of different possible sets of independent loops, the model that's fitted will be identical.
I understand.
So we don't need to choose between the different possible models.
I understand it in terms of the p-value, but if you have a statistical significance and then you want to identify the, let's say, problematic loops, then how can you do?
Oh, okay, sorry. So exploring the potential causes of inconsistency. Yes, so you mean which model we choose to use to explore the potential causes of inconsistency?
Exactly.
Yes. Okay. Sorry. Okay. I don't think we would have to look at all the possible models. I think it would be fine to look at a small number, and what we found so far, and what I suspect, is that the evidence for inconsistency will be in the same part of the network. So I don't think it's necessary, for example, to look at 50 different models and 50 different plots, which I agree would be very hard work.
Okay, so
Okay.
like it doesn't matter, like the conclusion will be the same regardless of the group of loops chosen.
This is what I think so far, but
Okay.
we do need to do more work in the simulation study, but we suspect that the area that shows the most inconsistency will be in the same part of the network for each of the models. So in practice, we wouldn't need to look at all of them. Is that okay?
Okay, thank you.
Okay, thank you.
The next question is, can this method be applied to check for inconsistency when we do a network meta-analysis in drug class, instead of just combining dosage across several drugs in several RCTs?
Ah, okay, drug class. So I think this might be about lumping or splitting doses, I think. Yes, this method can be applied to check for inconsistency in that kind of model as well. Yes.
Okay, and the last question by Federico again is about multi-arm trials. So can we say that this model has a strength to avoid overrating inconsistency, since in multi-arm trials it doesn't consider all pairs but only dependent ones? It seems to me that the forced inconsistency in multi-arm trials usually leads to underestimated consistency. But from the other side, I wonder whether trying to favor heterogeneity versus inconsistency in multi-arm trials may lead to underestimated consistency.
Okay, so yes, I think that because we're minimizing the number of loops and allowing more of the variation to be modeled as heterogeneity, this should help us to avoid underestimating inconsistency because we're saving degrees of freedom. So my view is to go with your point one. But yes, I see there could be another argument saying that favoring heterogeneity over inconsistency, yes, could lead to underestimating inconsistency, but my opinion is that one is correct.
Okay, and maybe a very last quick question from me. So have you implemented the method in software, maybe Stata or?
Yes, so we've implemented the method in Stata, and we're going to, so we've submitted a paper on this and we're going to make the code available, the Stata code available alongside it. Yeah.